Moving forward with our derivatives, we're now going to be looking at our trig derivatives. So in class I went through and I showed how to find these using our quotient rule, using the two trig derivatives that we had already found. We found the derivative of sine and the derivative of cosine just by looking at them graphically. Using those skills, we went through and we identified our 4 other derivatives. So the derivative of tangent is secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant x tangent x. And the derivative of cotangent x is negative cosecant squared x. So if you notice some patterns in there, all of our co-trig functions, their derivatives are negative. So the derivative of cosine is negative sine. The derivative of cosecant is negative cosecant cotangent, and the derivative of cotangent is negative cosecant. So using those patterns is really going to help you when it comes to applying these to derivative functions. I also learned a cool little trick here. If we were to say secant, secant, tangent, negative cosecant, cosecant, cotangent. So with just this little thing here, if I wanted to know the derivative of tangent, I could cover the tangent there, and I'm looking at secant squared. But if I wanted to know the derivative of secant, I cover the secant, and there's my secant tangent. Again, derivative of cotangent is negative cosecant squared, and then the derivative of cosecant is negative cosecant cotangent. Little helpful hint, and then you have to just memorize your sine and cosine. So knowing those, we can now take the derivatives of trig functions. So I've got a couple of examples up here for us. So here, I want to take the derivative of my function y. So I'm going to get dy dx equals the derivative of sine is cosine x minus the derivative of tangent x is secant squared x. And there's my derivative. So there's real no trick to these, no power rule, quotient rule. It's just knowing the derivatives. We have to have them memorized. So here, I do have a product though. I have cosecant times cotangent. So when I take the derivative, I'm going to have to use the product rule. So left, d right, the derivative of cotangent is negative cosecant squared plus right, d left. The derivative of cosecant is negative cosecant cotangent. Notice here that the variable is theta. The theta just kind of goes with us, okay? So technically here the derivative of y would be dy d theta because our variable is theta, not x. So I would just simplify here. This is going to become negative cosecant cubed of theta plus, nope, that's going to be a minus cosecant theta cotangent squared theta. Left d right plus right d left, and then I just simplified. There's my derivative. Okay, nothing really fancy. So I've got one more here for us to practice. This one is a quotient rule. So to take the derivative here, my variable is x, so I'm just going to say dy dx. I'm going to have low d high. The derivative of cosecant x is negative cosecant x, and then the derivative of negative cotangent is a positive cosecant squared. So low d high minus high d low. So the derivative of cosecant is negative cosecant cotangent, and then the derivative of cotangent is negative cosecant squared. Whoa! All over my cosecant x plus cotangent x squared. All right, so there's got to be some simplifying going on here. There's got to be something. Just taking a look. We're going to have to FOIL together and simplify, but for time's sake, Remember the rule, if I said take the derivative and you did, derivative's done. If you want to know that simplified, come ask me and we'll work through it. Derivative's a trig. Go forth.